Hello friends, today we are going to discuss about highest common factor, in short HCF. What is HCF? The greatest number which divides each of the two or more numbers is called HCF or highest common factor, also known as greatest common divisor. Today we'll see how to find HCF using the method you have already learned, that is by prime factorization. And we'll also learn a new method to find the HCF. So let's find HCF of 75 and 60 using prime factorization method. Okay, how do we do this by prime factorization? We'll write each number as the product of prime factors. So how will we write 75? 75 equals 3 into 5 into 5. That is 3 into 5 square. Now, how will we write 60? 60 equals 2 into 2 into 3 into 5. That is 2 square into 3 into 5. The product of all the common prime factors is the HCF. The common prime factor in this example is 5 and 3. The lowest power of 3 is 1, which means 3 is a common prime factor. And lowest power of 5 is 1, which means that 5 is a common prime factor. So HCF is 3 into 5, that is 15. So HCF of 75 and 60 is 15. But it's a bad idea to use prime factorization to find the HCF of really large numbers. What do we do instead? Can you find HCF of 17,925 and 3,456 by prime factorization? One more question. Find HCF of 39,203 and 21,583 using prime factorization. Try this out. Tell me how much time you took to solve this? It's really a long procedure, right? Finding prime factors of really large numbers is not easy. Well, it's easy enough, but it's very time consuming. We can use Euclid's algorithm to solve this in very few steps. So let's see how can we do this. Euclid's algorithm. We will find HCF of 60 and 75 using Euclid's algorithm. Here, first we'll see the steps to find HCF using Euclid's algorithm. After that, I'll explain it using a simple diagram. Here, we have two numbers, 75 and 60. What we have to do is divide the greater number by the smaller number. So 75 can be written as 75 equals 60 into 1 plus 15. In the next step, divisor in the first step will become dividend in the second step and remainder in the first step will become divisor in the next step. So 60 equals 15 into 4 plus 0. We have to continue this step till the remainder is 0. Once the remainder is 0, the procedure stops here and the divisor at this step will be the HCF. So here we got the remainder as 0. So our HCF is 15. Now I'll make the concept clear using a simple diagram so that you will get a better idea of finding HCF using Euclid's algorithm. Here we need to find the HCF of 75 and 60. For that, consider a room of length 75 and breadth 60. What I have to do here is I have to fill the room perfectly with the square tile. The largest square tile used to fill the room completely will be the HCF. So here what you have seen is the room of length 75 and 60. Now we are going to fill this with a square tile of size 60. A small portion of length 60 and breadth 15 is left out. Now we have to fill it again. Let us complete this area with 4 square tile of size 15. There are no portions left now. Hence, the maximum size of the square tile that can be used to fill the room of length 75 and breadth 60 is 15. So, HCF of 75 and 60 is 15. Let us do one more example. HCF of 85 and 51. To find HCF of 85 and 51, we assume a room of length 85 and breadth 51. To fill the room perfectly, I am using a square tile of size 51. It doesn't fill the room completely, right? A portion with length 51 and breadth 34 is left out. Now, let us fill this portion with a square tile of size 34. Still a portion is left out. Now we have to fill the remaining portion whose length is 34 and breadth is 17. So we'll use a square tile of size 17 to fill it completely, to fill it perfectly. Here, the square tile of size 17 can fill the whole room perfectly. So, HCF is 17. This is what Euclid algorithm says. 85 can be written as 85 equals 51 into 1 plus 34. Here, 51, the divisor, becomes dividend in the next step. And remainder 34 becomes divisor in the next step. So, 51 can be written as 51 equals 34 into 1 plus 17. Here, 34, the divisor, becomes dividend in the next step. And remainder 17 becomes divisor in the next step. So, 34 can be written as 34 equals 17 into 2 plus 0. Here we got 0, which means our procedure stops here. So, the divisor here in this step is the HCF. I hope the concept is clear. More videos for class 10 is coming, so stay tuned.